Okay, so after I graphed the exponential growth function, we're actually going to do another one, so the red one here. And so when I plug this into y equals, which looked like that, I went to the graph first just to see how it looked. And then you can see it kind of starts from the bottom and it curves this way. So I kind of think of that as I'm graphing it. I'm going to do the same thing I did before. And I'm going to graph just the points that I really can graph that I can fit on this grid. So I can do -1, -8. 1, 2, 3, 4, 5, 6, 7, 8. Then I can do 0, -4. Then I can do 1, -2. Then I can do 2, -1. And then I can do 3, -0.5, which is about halfway. And then I can probably do 4.2, -0.2, which is really close to my x-axis. So, all right, so I'm doing it that way. And this kind of looks almost opposite of the one I did before of the blue function. So I'm going to just kind of make arrows so people who will look at it know it keeps going. And I'm going to see if it will ever cross my x-axis or my numbers will ever become positive. And if you look, I'm only going to have negative numbers for that one. So it will never cross my x-axis. Which means I'll never have any positive y values, or my range will never be positive for that one. So now, after we've graphed both of those, let's look at the domain and range for each of them. So for g of x, I'll do g of x on this side. So for g of x, my domain is going to, my arrows are going to keep going. So I can keep plugging in x values here, and I can keep plugging in x values in the other way. It will never stop. So my domain is going to be all real numbers. Okay, and I just like to write it like that. It's just more simple. Or you could write it as -∞ to infinity. Okay, you could also write it in interval notation. My range, however, we talked about how this line will never go below my x-axis. So my range for here will never be negative. My y values will never be negative. So this line will approach 0. It'll get closer and closer to 0, but it will never actually be 0. Because even if you remember, 2 to the 0 power is 1. Okay, so my range is actually 0. And then although it's 0 on the low end, it will never actually hit 0. So that's why I use the parenthesis, not the bracket. This function will increase forever, and it will keep going up and up and up and up, and it will actually increase very fast. So I can say that my range will be all the way to positive infinity. And again, I'll just use those soft parentheses to indicate that it will never be equal to infinity. Okay. And that's the reason we never put a hard bracket with infinity, because you can never actually get to the number infinity. It doesn't really exist. But we can keep going and going and going forever. So similarly, or not similarly, h of x, we look at h of x. So the domain will be all real numbers. I can actually plug in every x I possibly can, right? And this way I can keep plugging in positive x values. I can keep plugging in negative x values. But my range, I'll never actually hit a positive number. So I can go all the way to negative infinity. My numbers will keep going down forever. So my range for this one will be negative infinity to 0, kind of backwards, but it will never actually hit 0 or become positive. Okay, and so I kind of answered the question for there too. I was supposed to put the range below. I'll put it right there. Okay, so that is exponential functions. All right, now I'm going to look at square root functions. Okay, so we're going to graph again 2 on this, and then we're going to kind of look at them and see what they look like. So first one I'm going to graph is just the square root of x. And so to put the square root of x, I'll just clear what's here. You are going to press second and then the x squared button, and that will give you the square root. And then you just put x in there, and you're going to graph it that way. And so you kind of see it looks like it starts at 0, 0, and it kind of just curves to the right. And because it will never go 0 or past 0, because if you look, I can have my table start at 0. It will never, there's an error every time I have a negative x value. And if you remember from last unit, you can never take the square root of a negative number. So that's why there's an error there, is because you can never take the square root of a negative number. So that actually restricts my domain. I can't plug any negative numbers in for x because I can't take the square root of a negative number. Okay, so that's, as we're talking about, the graph kind of comes from the middle, and that's because you can't take the square root of a negative number. So when I go to write my table, I can just plot the points just kind of I did before. I'm going to do z of x in blue. So I'll do 0, 0, 1, 1. The next nice one is 4, 2. And then I can do 9, 3. So it would look like that. Okay. And so then I'm going to just graph the other one in red. So that is the square root of x minus 4. And it looks, the minus 4 is under the radical 2. And then when I graph that, it just looks like that. Starts at 4. And because that is the way it is, because this will be a negative number anytime this number is greater than 5. Or that's less than 4. So like, for example, 2 minus 4, the x was 2. 2 minus 4 is negative 2, and I can't take the square root of a negative number. So that will, anything less than 4 will make that a negative number. So that's why I can't, my domain starts at 4 there. So again, I'll just kind of graph the numbers I can. So 4, 0. And then I'm going to do 5, 1. And then 8, 2. And I think that's all I can fit on this graph, so I'm just going to kind of do this. Okay. And so we'll kind of now look at the function. So it says, what are some characteristics? So it's a curve. For the square root function, you cannot take square root of a negative number. So this is not defined at all values of x for that reason. So the domain of that blue function is only anything greater than 0. I can only plug positive numbers in for that single x. Okay, so my domain would be, you could say x is greater than or equal to 0. You could write it as x is 0 to infinity, or you could write it using the interval 0 to infinity. So that's 3 ways you can write that domain, and that's of z of x. And so for v of x, my domain for this one is anything greater than 4. So I could write x is greater than or equal to 4. I could write x is between 0 and infinity. Or I could write it as, oops, this should be 4, I'm sorry, 4 to infinity, or you could write it from 4 to infinity this way. Okay? And so the range, well, in this case, my range, my y, there's only positive y values for my blue. There's not any negative y values. So my range for z of x is just from 0 to infinity as well. So you could write it like this. You could say y is greater than or equal to 0, or you could say 0 to infinity. So infinity that way too. Okay, so that's 3 ways you can write it. The range for the other function is the same, because My lowest y value is 0, and my highest y value, it just can keep going up, so it'll be the same for that. You can say y is greater than or equal to 0, or you can say 0 to y. Okay, so that's kind of what the square root function looks like and why no negative values can be under the radical, which we kind of already knew from before. The last ones we're going to look at are cubed functions. So I'm going to look at c of x on this graph. So I'm going to just start by plugging it in, and c of x is the same thing as y. It just means output. So I have x to the third power. I'm going to arrow down minus 3x squared minus 4x. And so when I look at this, it looks like that. You can kind of see it swoops. So you can see it kind of curves. So that's what our graph will look like. I'm just going to graph as many points as I can. You see this one crosses the x-axis 3 times. So that means it has 3 solutions if we're thinking back to last unit. So I'm going to plot this. So let me see. I can start, I guess I can plot those two. So -1, 0 I can plot. And then I also have 0, 0. And then I have 1, -6. And then that's all that I can put there. And then 4, 0. And then 5, 30. Okay, so this is where I can only plot that many points. So I have to look at my shape again to see how my graph is going to look. So it is going to come from down here. It's going to go up and it's going to curve slightly. I'm just doing the best I can. And then it's going to kind of swoop down below my graph. And then it's going to come back up. And that's just the best I'm going to be able to draw here. But at least it shows me what my domain and range are going to be. And if you weren't sure, you can always zoom out. You can press zoom. And you can zoom out and just kind of press enter, and it will zoom it out for you. So you can kind of see that function more and more what's happening in the function. If you want to get back to your standard window, just press zoom and then 6 for a standard window there. Okay. So if I look back at the graph, so I know my domain, I can plug anything in for x. So my domain is going to be all real numbers. Okay. Or you could say negative infinity to infinity. There's a bunch of different notations there. My range is again going to be all real numbers because it goes on forever up and it goes on forever down. I could check that in my table, but it's also all real numbers, and I could use it that way too. And so characteristics of this function, so it kind of increases, decreases, and then increases again. So it has 2 turning points most of the time, sometimes. And then this, so those are just kind of some functions about it. This one, anything that has a greater x value than 2 can cross the x-axis that many times. So quadratics, remember the U shape would only cross at the most twice. These can cross as many times as your exponent, the largest exponent. So, and then there's just this box down here. I know we've gone over it a couple times, but just to show you how you write domain in different ways. I know we were kind of just writing x as the real number, but this just stands for is. It's like a curved E. It just means x is in the real number. So that just means x can be anything in the real number set. And then these are just some other notation with the brackets and stuff like that. You can use any of them you want unless there's a multiple choice that just has one. You just have to kind of know what it means. So that is all different kinds of nonlinear functions. The practice has both domain and range, and then it just has you practicing graphing functions. So that's really all the practice is. And then on Monday, we will start 7.2.